Hey Jackson,
Hey, how are you?
I'm doing good. How are you?
Good.
So what are we working on today?
We're working on some trig kind of stuff.
Okay. What do you got in the way of problems?
I have, hold on, let me find it. Okay, here we go. Should I try to email you a picture of it?
It depends. If it's something you can verbalize, go ahead and verbalize it. If it's something that we have to look at, then email it to me.
Okay, I can probably verbalize it.
Okay?
Okay, so the first one has a triangle with a 70 degree angle, and we're trying to find the hypotenuse, and the two sides are 15 and 22.
Which sides?
It A and B, the vertical and like bottom.
Is the vertical 15 or the horizontal 15?
The vertical is 15.
The horizontal's 22?
Yeah, and 70 degrees is on like the right angle looking thing.
All right, that's a right angle. So which is the 70 degrees? It must be
No,
this,
the
must
70
be
degrees
this one.
is no, the 70 degrees is where the right angle is.
Ah, it's not a right triangle.
No.
The 15 that is obviously not opposite the 22, or where's is this right?
The 22 is on the bottom.
All right. And what's the problem one?
We're trying to find X, which is the other side.
All right. That's not the hypotenuse, incidentally. In other
Oh,
words, the hypotenuse only applies if you have a right triangle,
okay.
something that looks like this. In other words, the hypotenuse is by definition always opposite the right angle.
Okay.
Okay? So, you apparently have dealt with the law of cosines.
Yeah.
All right? Well, let's get rid of that. Tell me what the law of cosines says x squared should be.
Isn't it A squared plus B squared
Okay?
times the quantity of -2 times A times B?
Yeah, it's not times, it's minus. So what's a squared and b squared here?
15 squared and 22 squared.
Minus 2 times what?
A times 15 times 22. And then times the cosine of 70.
Okay. In other words, what we have here is side angle side. You know what I mean by that? In
Yeah.
other words, we have a side, and then we go right to left, we have an angle, and then we have another side.
Yep.
Pretty much classify triangles as side, angle, angle, side, angle, side, things like that. So,
Okay.
in this case, there's only one unknown here. What is the unknown?
The side.
X. Exactly. So, in other words, we know what that number is, we know what that number is, we know what cosine of 70 degrees is. So,
Mm-hmm.
x is equal to the square root of all of this. That's 225. What's 22 squared?
It is 484.
30 times 22 is 660. What's the cosine of 70 degrees?
It's 0.3420200143.
Now let's come up with x. In other words, add those two, subtract that, and then take the square root of it.
Okay.
What's 660 times point that, whatever that decimal was?
Hold on, I'm just going to do the whole. 660 times the decimal is 224.4.
And what's the square root of that difference?
224. It is, hold on a second, I gotta find it. 22.013.
How much do they want you to round it off to? How many?
The nearest whole number, so 22.
Okay. Now, you got to be a little bit careful here about round-off error. Okay?
Okay.
You can come up with the wrong answer just because I rounded this 0.34 down, and I rounded that down, and then I rounded this down. Well, we're probably safe because this is awfully close to 22. But it's better if you don't round off anything until you get to the end. Okay. What kind of calculator do you have, Jackson?
Casio.
Is it an Inspire, a TI Inspire? Is it just a Casio, nothing special? It's not a TI-84 or a TI-83?
FX260.
Okay. Yeah, you just want to be careful. In other words, if this was rounded up and this was rounded up, it's always possible to come up with the wrong number if you round off early. So you want to be careful. If you can avoid it, do not round off early. Round off only when you get to your final answer.
Okay.
Now, this answer makes a little bit of sense. The one thing you know about all triangles is that the longest side needs to be opposite the longest angle, the biggest angle, and the shortest side needs to be opposite the smallest angle. Well, if this is 22 and that's 22, then this must be approximately 70, and this would be about 40. And that picture makes sense. Always make sure that the picture makes sense. In other words, you can catch big errors sometimes that you've made in arithmetic by just looking at the picture and make sure that it fits. In other words, you wouldn't want to come up with an answer that was less than 15, right?
Yeah.
In other words, if I came up with 12, well, that can't be right. There's no way that 12 can be opposite 70 and 15 can be opposite whatever that angle is. So just always check your final answer.
Okay.
Do a mental ballpark check is what I mean.
All right.
Okay, what else you got? Incidentally, let's talk about the law of cosines. There's only two instances where you use it. One is where you have side, angle, side, like that. And the other is where you have side, side, side. Those are the only two.
Okay.
Any other situation, in other words, they always have to give you three pieces of a triangle before they can ask you to solve it. There's no way to solve a triangle if you only have two pieces of it. Okay? So they can give me an angle, and they can give me a side there, and they can give me a side there. Well, this is side, side, angle, And because we have an angle and its opposite side, we would use the law of sines to solve that.
Okay.
In fact, every single triangle that you solve, you are going to have to use the law of sines. Only two cases where you start out by using the law of cosines are these two.
Okay.
Where you have side, angle, side, or side, side, side.
Okay, cool.
Both of these cases, you're going to solve for either an angle or a side, and then you're going to solve the rest of the triangle using the law of sines. So you have to use the law of sines on every single triangle. But you only use the law of cosines when you do not have an angle opposite side relationship. In other words, I don't know what x is. I have an angle 30 degrees, but I don't know what x, so I can't use law of sines yet. And over in this case, I don't know an angle. In order to use the law of sines, you have to have an angle and its opposite side.
Okay, cool.
Okay. What else you got?
I have one. It's another triangle, and x is one of the sides, and another side is 19. And then there's two angles with 59 degrees and 86 degrees.
Which is opposite x?
There's no angle labeled opposite.
What's opposite 19?
86.
What's this angle again?
That's 59.
So they've given us two angles and a side.
Okay.
But they've really given us three angles and a side, right?
Yeah.
Because what's this angle here?
If you add both the other angles.
Do that and subtract from 180. What do you get?
You get 38.
I got 35. When I add 59 and 86, I get 145.
Okay, I added
subtract that from 180, I get 35. So whenever they give you two angles, they're really giving you all three angles. Okay? Now we have an angle and its opposite side. So what are we going to use to solve this triangle? What law?
Sine.
Law of sines. So tell me what I can write. What kind of an equation can I write?
Sine of 38 over x.
Where are you
equal. Huh?
You mean 35?
Yeah, I mean 35. My bad. Equals 86. Sine of 86 over 19.
All right. There's your equation. There's only one unknown there, and it's x. This is a number, this is a number, that's a number. So how do I solve this?
You cross multiply.
Okay, so I get x sine of 86 equals 19 sine of 35. So what's x equal to?
X is equal to, hold on. Hold on, I messed that up.
These can be a little tricky to put into your calculator. And sometimes it's better to just do it one part at a time. Do 19 times the sine of 35, and then take that answer and divide it by the sine of 86.
Okay. So 35, the sine of 35 times 19 equal. And then divided by the sine of 86?
Yeah. And that you either have to put it all in parentheses, or in other words, the tricky part of the calculator is getting it in so that it's calculating what you want it to calculate.
Mm-hmm. I got 10.92.
All right. Let's see if that answer makes sense. 10.92. Now, what is the problem here? Is it to solve the whole triangle?
It's to find the side.
Just that side?
Yeah.
And we did that. And the only thing we can see at the moment is that it makes sense in that 19 is opposite 86 degrees, and a smaller number is opposite the 35 degree angle.
Mm-hmm.
So it makes sense visually.
Okay.
That doesn't necessarily mean that, your answer is correct. In other words,
yeah,
you have to make sure that this is what you put into your calculator.
Mm-hmm.
But I'm going to assume that you're doing that correctly. And let's go on.
Yeah.
In other words, as long as we didn't come up with a number bigger than 19. If we'd have come up with a number bigger than 19, we'd have known it had to be wrong.
Yeah.
And this side right here has to be between 19 and 10.92.
Okay.
Because this angle is between 35 and 86. In other words, this relationship in triangles is paramount. The largest side has to be opposite the largest angle. The smallest side has to be opposite the smallest angle. And the middle angle has to be opposite the middle side.
Mm-hmm.
All right. What else you got?
I got one that's... Let me find one that's harder.
Hold on one moment.
Okay.
Let me just go back and look at this because let's just make sure this is not... Have you heard of the ambiguous case of the law of sines?
No.
Okay. Well, if you haven't heard about it, then I probably don't need to cover it. So let's go on.
Okay, it has there's another triangle, and it gives you two sides, and they're both 23. And then it gives you the one angle that's 31.
Is it opposite one of those sides?
Yeah, it's opposite one of the 23s.
What does this angle have to be?
It has to 31.
Exactly. In other words, we're looking at an isosceles triangle, and not only do two sides have to be the same, but the two angles opposite those sides have to be the same.
Okay.
What's this angle right here?
It's oh, hold on. It is 118.
Okay. So we know 5 pieces of this triangle. How are we gonna get the 6th piece? And I assume that's what they're asking for, is that side?
Yeah.
Okay. So give me an equation I can write.
Sine of 31 over x
No.
equal.
No. When you use the law of sines, it always has to be the sine of an angle over its opposite side.
Okay.
So it would have to be the sine of 31 over 23.
Oh, okay.
Equals what?
Equals the sine of 31 or the sine of 118 over x.
Okay. Now, let's just talk about this for a second. The law of sines does not matter whether you have the sine on top or bottom.
Okay.
So I could have written this 23 over sine of 31 equals x, over sine of 118.
Mm-hmm.
Okay? That
Okay.
seems insignificant, but in reality, it makes this easier to solve.
Yeah.
If I'm going to solve this problem here, I have to cross multiply.
Okay.
If I'm going to solve this problem here, is all I have to do is multiply both sides by this sine of 118.
Mm-hmm.
In other words, this is one step, this is two.
Yeah.
In this case, x is equal to the sine of 118 times 23 divided by the sine of 31. One step.
Okay.
In this case, I'd have to cross multiply, and I get x sine of 31 equals 23 sine of 118. Then I have to divide both sides by sine of 31. So I get to the same answer. X equals all of this, or all of this. But notice that when my variable or my unknown was in the denominator, it took two steps. If you put your unknown in the numerator, it'll always only be a one-step problem.
Okay.
In other words, when you have this problem there, you don't need to cross-multiply. Cross-multiplying is not the best thing to do. I'm trying to solve for x. So all I need to do is multiply both sides by this denominator. And I solve for x. So when you set these up, it's worth keeping that in mind. It isn't always the sine of A over A equals the sine of B over B. Sometimes you can say A over the sine of A equals B over the sine of B equals B over the sine of C. In other words, either way is correct. The law of sines works regardless of which orientation you use. But sometimes it makes the problem one step easier if you put your unknown in the numerator. Like we did here.
Okay.
You can see that most triangles you're going to solve by using the law of sines, not the law of cosines. The law of cosines is very specifically used only when you have side, angle, side. Use the law of cosines there, and you use the law of cosines when you have side, side, side. No angles at all. Those are the only two situations where you would start the problem off by using the law of cosines. You would still have to use the law of sines as your second step, but your first step is going to always be the law of cosines. Right, what else?
I have one that's it's another triangle, and it has 89 degrees, and opposite of the 89 degrees is a 13. And then it has x degrees at the top, and 6 is opposite x.
What are we going to use here to solve this? We have three pieces of information. And that's usually all we need.
Oh, so we're just going to use the law of sine again.
Okay, good. What equation can I write? Then let's this time make sure that's in the numerator.
Okay, so you can do 13 over the sine of 89, and then x over the sine.
You can't switch it unless you switch everything.
Okay, so it'd be the sine of 89 over 13, and then equals sine of x over 6.
There you go. In other words, you can switch it as long as you keep it the same in your equation. You can't switch one side of the equation without switching the other.
Okay.
So you always need the angle either on top or bottom and the side on top or bottom, but it has to be consistent for that triangle. So now, what's the next step? Sine of x equals what?
It's sine of x and then times 13 equals the 6 times the sine of 89.
Back up one step. You don't need to cross multiply here.
You don't?
No? So all you need to do is multiply by this denominator. That's why we set it up with the variable in the numerator.
Okay.
You see where it saves you one step by not cross multiplying?
Uh-huh.
In other words, let's say we cross multiply. It doesn't hurt you, it just costs you a step. In other words, if I cross multiply here, I get this. Well, then I have to divide both sides by 13.
Yeah.
Well, dividing by 13, I just multiplied by 13. So there's no need to cross multiply and then have to divide by 13. Let's just take this side of the equation. Since we're solving for x, let's multiply both sides by 6.
Okay.
That gives us this. Now, how do we solve for x? Because we're not trying to solve for sine of x, we're trying to solve for x.
Do you divide both sides by sine?
No, this is where you take the inverse sine. Let's talk about inverse sine for a moment.
Okay.
We take the trig function of an angle to get a ratio.
Mm-hmm.
We take the inverse sine of the ratio to get the angle.
Oh, okay.
This is by definition. If one of those is true, the other is true.
Uh-huh.
And it's an important thing to think about and remember, is that we're always taking trig functions of angles and we're getting numbers. Well, if you want to find the angle, then you take the inverse trig function of the number and you get the angle. Okay, so in this problem, we're trying to find an angle. And what we have is a number. In other words, convert that to a number quickly.
Okay, hold on. Uh, 0.461.
Okay. Now, what's the angle x going to be? If the sine of x is equal to 0.461,
The sine of negative, or the inverse sine, so it'd be 27.48.
now here's where it's really important that you know what your calculator is in. Your calculator needs to be in degree mode, not radian mode.
Okay.
Have you had radians yet? Do you know what radians are?
No.
Okay. So your calculator may only have a degree mode on it. I don't know. There's two similar measurements. One is degrees, one is radians. And at some point, you have to make sure you know which one your calculator is in. Otherwise, you don't know if this answer is in degrees or if it's in radians. This looks like degrees would be correct. Let's go back and look at our 27.48. Now let me put that in there. Does that answer look right?
We're going for the angle, actually.
We're going for the angle. Excuse me. What was this number again?
6.
6. So this angle is 27.48. Does that make sense?
Yeah.
Yeah, it does. Smaller angle versus smaller side, bigger angle versus bigger side. What's this angle here? And is the problem here merely to solve for that angle, or is it to solve the whole triangle?
Just to solve for that angle.
Okay. You can see that ultimately you're going to be asked to solve the entire triangle.
Yeah.
Well, this is pretty easy to solve from this point. We got two angles, so I know this angle here. This angle here has to be 62 or 63.48 just by adding these two and subtracting from 180. And once I have this angle, using the same law of sines, I can come up with that side there.
Okay.
Okay? So is all they need to do is give you three pieces of information before you can solve the entire triangle. Well, you're in Law of Sines 101 at the moment, so they're only asking you to solve for one piece. But at some point, they're going to ask you to solve the whole triangle. All right.
Okay.
What else you got?
There's some area problems on here. It's a triangle with one side 122 and the other side 47. And then opposite, like, the blank side is 48 degrees.
So that's 48 degrees. This side is what?
122.
And this side is?
47.
All right. This is side angle side. You see why?
Yeah.
Okay. When you have side angle side, there is a special formula you can use for area. Notice that area is normally 1/2 base times height. The problem is I don't know what the height is here. If I use that as the base, I would need that distance there. If I use this as the base, I'm going to need this distance here. I don't have either of those distances. But there's a formula specifically when you have side angle side where the area equals 1/2, not the base times the height, but the two sides that you have, times the sine of the angle in between them.
Okay.
Where this is A, this is B. So what would this be? The area would be 1/2
122 times 47.
Times the sine of 48 degrees.
Okay.
Now, let me just point this out. Because sometimes it helps to remember it, if you remember this. If this is 90 degrees, and I knew this side was 3 and this side was 4,
yeah,
my area would be 1/2 3 times 4 times the sine of 90 degrees, which is 1.
Yeah, 1.
Which means that it was really 1/2 base times height.
Okay. So it's just 6.
Right. But that's only for a right triangle, where that's 90 degrees. If you're using this special area formula, you have to multiply 1/2 base times height times the sine of the angle in between. It's just that I find it useful for memorization to know that, well, if I use that formula right there, in other words, I don't need that formula there, but it fits. In other words, I could still use the formula for the area, and it would come out to 1/2 base times height.
Okay.
So it helps you in memorizing it. Whenever you memorize it, make sure that it fits the right triangle also. In other words, we wouldn't want that to be cosine. If you mistakenly wrote cosine of 48, it would not fit this picture because the cosine of 90 is 0.
Yeah.
So make sure that it fits the picture of the right triangle, that you know how to calculate the area.
Okay.
Okay? And this formula is really, you're only going to use it when you have side angle side.
Okay.
Have you had Hero's formula or Heron's formula yet?
No.
Where you have 3 sides and they want you to figure out the area?
I haven't had that one yet.
All right, let's not cover it.
Okay, and that actually is all that I have for the day.
Okay. Well, let me think. Let's see. So today was law of sines and law of cosines.
Yeah.
And you have not had anything called the ambiguous case of the law of sines. Well, let me just talk about it. You may or may not get it. It's the only tough part of any of this. In other words, the law of sines is very straightforward. The law of cosines is very straightforward as long as you know which situation to use them in. There is one triangle, or one type of triangle, where it's side-side angle. This one right here. We have a side-side angle in that order.
Okay.
When you have this problem, you potentially have 2 possible triangles. You can have this triangle here, but you can also sometimes have this triangle here. And notice that nothing is different of this triangle. I still have 30 degrees, 10, and 8. Just like I have in this triangle up here. But this is a different triangle. It's not the same triangle as this one. So if they give you this problem where they say this angle is 30, opposite the 30 is 8, and then between the angle and the opposite side is a side 10, well, it might be that triangle right there.
Okay,
and
but it could be
it's
any
called
other.
the ambiguous because it can be either one.
Yeah.
And there's a special way to deal with that. I don't need to cover it because you're taking geometry, right?
Yeah.
In geometry, they're going to give you a little bit of trig, not a lot, just a little bit.
Yeah.
I'm a little surprised that they've already given you the law of sines and the law of cosines, but they haven't given you enough trig to force you to deal with this problem right here. So I won't, because you're going to take Algebra 2 next year. You might get a little bit more trig. You probably don't have to deal with this problem for 2 more years when you actually take trig. When you actually take trig, you're going to have to deal with the ambiguous case of the law of sines, which is when you have side-side angle and the angle is less than 90 degrees, then sometimes you can end up with 2 possible solutions. And there's a way to handle it, an easy way and a hard way. I don't really want to confuse you with either way at the moment because you're not having to deal with that. So every problem you're dealing with at the moment, you can probably assume that it looks like that. Okay? And that you're not going to have to deal with the ambiguous case of the law of sines. And you would know it if you had dealt with it, because that word has to be used, ambiguous. If you have not dealt with the word ambiguous in your geometry class, then you have not dealt with this. When you deal with this, they will call it the ambiguous case of the law of sines. That's the only thing to call it. So Since you're not familiar with that word, we don't need to cover it.
Okay.
The only other thing I should mention is that the law of cosines, let's just take a quick look at this problem here. Solve this for angle x.
Okay.
At least set it up.
Okay, so what's the law of cosines again?
Well, there's three of them. It's c squared equals a squared plus b squared minus 2ab cosine of c is 1. A squared is equal to b squared plus c squared minus 2bc cosine of a. And finally, the third one is b squared equals a squared plus c squared minus 2ac cosine of b. Do you see the pattern?
Yeah.
In other words, these two letters are always these two letters.
Yeah.
This angle is always the angle opposite that side.
Okay.
So, if I was trying to solve this problem, well, if they say solve the entire triangle, then I can pick any side I want to start. If they said solve for that angle, then I'm going to let that be the left side. I'm going to say 7 squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of what?
Cosine of 7.
Of angle opposite 7.
So x.
There you go. Now notice there's only one variable in that equation. This right here. So the way we would solve this, and let's go through this because this is important. You do have the law of cosines you have to know. And it's not 100% obvious how you solve these. Well, that's 49. 36 plus 64 minus 2 times 48, 96 cosine x. Add these two numbers together, they're 100. Subtract from both sides, you get minus 51 equals minus 96 cosine x. Next, divide both sides by minus 96, and you get cosine of x equals this number.
Okay.
What is x equal to? Remember, if you're solving for an angle, you always need to be talking about inverse.
X is 57.91.
Well, what is it? It's the inverse cosine of 51 over 96, right?
Yeah.
Okay, what is that equal to?
57.91.
Okay. What if you were going through this problem and you came up with something like this? What does that mean? Solve for x now.
Okay. So it's the invert cosine of negative 96 over negative 87 equals x.
Okay. What do you get?
You get...
Your calculator coughed. Why is that?
I don't... Because the numerator is higher than the denominator.
There you go. In other words, cosine of x has to always be between 1 and minus 1. And this number is greater than 1.
Yeah.
When you get that, what it's telling you is that you have an impossible triangle. In other words, you would get that if I gave you a triangle instead of 6, 7, 8. Let's say I gave you a triangle of 6, 7, 14. That's an impossible triangle because there's a rule of triangles that says any side of a triangle has to be less than the sum of its other two sides. So there's no way you can have a triangle where that side's 14 because this is 6, that's 7, that's 13. This side has to be less than the sum of the other two. So if they gave you a triangle that was an impossible triangle and you went to solve it by using the law of cosines, the way you discover that it's an impossible triangle is you end up with the cosine of an angle equals a number greater than 1. Or less than minus 1. In other words, it would be just as bad if I had cosine of x equals minus 1.1. That's impossible also. Sines and cosines are always between 1 and minus 1. So even if you're using the law of sines to solve a problem, if you end up getting the sine of an angle equals 1.02, that's impossible. You have an impossible triangle. Okay? And that's how you know. In other words, you don't have to apply those rules of geometry, although that's worth knowing. When you go to take the SAT test or the ACT test, that's one thing you are going to have to know, is that any side of a triangle is less than the sum of the other two sides and greater than the difference. Notice that 6 is less than 14 plus 7, but it's not greater than 14 minus 7. So this is an impossible triangle based on this side or this side or this side. 7 would have to be less than the difference between 14 and 6. And it's not. It's not. So when you have an impossible triangle, it usually flunks all the tests. But the main test to remember, and you really only have to remember the first half of it because the second half is the opposite. And the first half says that any side has to be less than the sum of the other two sides. The second half of that is or greater than the difference of the other two sides. Those two rules apply to all triangles. Notice that if I tried to draw a triangle that had a side of 6 there and a side of 7 there, there's no way that side could be 14. The shortest distance between 2 points is a straight line. And I'm saying that, well, the shortest distance between this point and this point is 14, but if I go the crooked way, I only go 13. That's impossible. So that's kind of the way to look at triangles, as to remembering that rule, as to why any side has to be less than the sum of the other two sides. All right. How's your math going in general, Jackson?
It's getting better.
Yeah? Okay. You have any last questions?
Nope.
Okay. Well, let's call it a day. And you got a final coming up soon?
Yeah, like a week from Tuesday. Or Thursday.
Okay. Well, if you need 1 or 2 sessions between now and then, let me know. You know how to schedule it. You did this one online, didn't you? Okay. Sounds good. I will talk to you next time.
All right, thank you.
You're welcome. Bye-bye.